Okay, so let's find some easy limits, and let me explain why these are easy limits. So first I have to tell you what an elementary function is. So almost all of the functions that you've ever known or heard about are elementary functions. Elementary functions include polynomials like x squared or x squared plus 1 or really any power of x. They include roots like you can have the square root of x, cube root of x, this type of stuff. Exponential functions like e to the x. Logarithms like natural log of x or log base 2 of x. It includes all trig and inverse trig functions, and a lot more because you can build elementary functions from other elementary functions by combining them. I can take an elementary function plus another elementary function, and that's an elementary function. I could multiply two elementary functions, and the result is considered an elementary function. I could divide them. I can also use composition. Composition, once again, is referring to things like f of g of x. So I can plug an elementary function into another elementary function. So, for example, arcsine is an elementary function, and e to the x is also an elementary function. So if I were to combine them by saying like, I need somewhere to write this, so I'll just kind of make a bubble up here. I can take e to the x and plug that into arcsine, and this would be an elementary function. So I can really combine them in a lot of ways, and these are all called elementary functions. One common thing that you've probably seen that is not an elementary function is a piecewise function. And this is part of an example that we'll get to in a minute, but I just want to show you this. A piecewise function is one that looks like this. Usually you have this curly bracket, and then you have one formula for values of x that are in a certain range, and then a completely different formula for other values of x. If that's what you have, if you have different formulas for different values of x, then this is not considered an elementary function. Even though this one by itself would be an elementary function, and this one by itself would, the fact that I'm not always using this formula, I'm only using this formula for certain values of x, and I'm using this one for other values of x, that's not an elementary function. But the important thing is elementary functions are continuous on their domain. What does continuous mean? Continuous means that you can just find the limit by plugging the value of x in. Like if x is approaching a, you just plug in a. And in the last couple of videos, I emphasized that that's not always the case. In general, just plugging in a doesn't tell you anything about the limit as x goes to a. But for elementary functions in their domains, it does. So I just said kind of a lot of big words, but what that means is that these limits are easy. This is an elementary function. This is a polynomial. So the way I find this limit, I can just plug, since x is going to 1, I can just plug in x equals 1. It's as easy as that because this is an elementary function. Cosine is another elementary function. It's a trig function. So if x is going to pi, I just have to do cosine pi, and figuring that out is maybe the hard part, but that would be -1, right? Because if I draw a little unit circle, pi is the same as 180, so that's like this angle. So if I follow that out to the point on the circle, keep in mind that cosine is the x-coordinate, so the x-coordinate at this point is -1. Okay. Now, this is another elementary function. Of course, this one looks a little bit crazier, but keep in mind that this x squared minus 1, that's just a polynomial. And what I did is I put that inside of a root, and roots are elementary functions. And then I divided that by another elementary function. So this is just examples of ways you can combine elementary functions to make more elementary functions. So this thing, even though it looks a little bit crazy, is just an elementary function. So I can get my answer by just plugging in 2. Of course, as I do this, I should make sure that this really is in the domain. Sometimes when you do this, you find yourself dividing by 0 or something, and then you have to figure out something else to do. But that hasn't been a problem yet. And that's still not going to be a problem now, because I get, what, square root of 3 over natural log 2. I'm allowed to do the natural log of 2. I can do the natural log of any positive number. So this is my answer there. Okay, so let's talk about part D. And D was this piecewise function. So this is a common type of problem in calculus. That this is an interesting problem where the limit may or may not exist. So what we see here is we see that we're having two different rules when x is to the left of 1 and when x is to the right of 1. And we're being asked the question, what happens when x goes to 1? Typically, what you do is you do a left limit and a right limit. The limit as x goes to 1 from the left. If x is going to 1 from the left, then I should use the formula for x smaller than 1. So I copy that formula down. Now that I've got that down, this is an elementary function. X plus 1 is an elementary function, so I can get this just by plugging in x. And so keep in mind x is going to positive 1 from the left, so I'm going to write 1 plus 1. Okay. Similarly, I can do the right-sided limit. The limit as x goes to 1 from the right. And if I know that I'm going from the right, I should use the formula for x larger than 1, which is x squared. This is an elementary function, so I can just plug it in. And here I get 1. And now, so how do we draw our conclusion? Maybe you already know. Well, the left limit and the right limit did not agree, so, oops, there I go writing an equal sign when I shouldn't. So the standard limit doesn't exist. The two-sided limit, when I'm not specifying a side, that doesn't exist. By the way, of course, this could have worked out differently. We could have gotten the same number here and here, and if that was the case, then I would say this is whatever that common value of the two limits was. So that's the two ways that a problem like this can work out. Either these two give you the same number, and then this is that same number, or these two don't give you the same number, and you say this one doesn't exist. Okay. So what now? Maybe, yeah. Let's talk about these. So these are just more limits, and they look very similar to what we just did. This is an elementary function. It's the top is a polynomial, the bottom is a polynomial. So I could potentially get this by just plugging in x equals 2. But if I do that, this time I am going to find a domain problem. In particular, I'm going to get 0 on the bottom, because the bottom is 4 minus 2 minus 2. So I know I'm in trouble, but let me, just for fun, well actually more than just fun, let me figure out the top as well. Of course, maybe the top doesn't matter. You could say that as long as if the bottom's 0, then you're in trouble. But I think I do care about the top. So the top would be 4 plus 2 minus 6, which would also be 0. So this is why I emphasized elementary functions are continuous on their domain. This is an elementary function, but we're not in its domain because plugging in 2 results in division by 0. So here's what we can do instead. Maybe let me put a little bubble around this so it doesn't bother us. And let me tell you why I went to the trouble of figuring out the top. If you're getting 0 over 0, then typically that means you can factor something and cancel it. So we should try to factor the top and the bottom. So hopefully we remember how to do this. And let me try to be smart about this. Since I'm getting 0 over 0, I'm going to just go ahead and guess that there's a factor of x minus 2 on the top and bottom, because that's exactly the type of thing that would cause me to get 0 over 0. Of course, at this point, maybe that's just a guess, but that can help us successfully factor it. So the top looks like it would be x minus 2, x plus 3. So now that I see that, now I'm more confident that writing x minus 2 was correct here. The bottom looks like it could be x minus 2, x plus 1. So now I'm more confident all around. And now I can just cancel these. And now I plug in x equals 2. After doing this cancellation, I find that I can plug it in. I don't get 0 over 0. I get 5/3. So that's going to be my answer. And right, so the important thing here is x isn't exactly 2. When I'm doing the limit as x goes to 2, x is just a number that's very close but not exactly equal to 2. If it was equal to 2, then we would be in serious trouble. We would just have to say this is undefined. But if it's just close to 2, then I can just cancel these two things. So, yeah. Let's do another one like that. It's this. Sorry, I changed my mind about what would be in the denominator of the fraction. So it's this over this. And again, the first thing I should do is just try to plug in 5, because this is an elementary function. As long as I don't run into any trouble like dividing by 0, then plugging in 5 is just going to be my answer. Unfortunately, we are going to see that we're getting 0 over 0 again. Because, yeah, I get 2 times 25 is 50, minus 25, minus 25. So I'm getting 0 on the top. I'm also getting 25 plus 5 minus 30, so 0 on the bottom. So this tells me that I can't just plug in 5. Most likely it's going to work out like the last one where I factor and cancel. So on the bottom, once again, I'm going to guess that one of my factors is x minus 5. And it looks like I can do x minus 5, x plus 6. Now, on the top, I'm also going to guess that one of my factors is x minus 5. But then, yeah, how should I do the rest? Well, since I want to get a 2x squared, probably this should be a 2x. And since I want a minus 25, maybe this should be a plus 5, because positive 5 times negative 5 would be negative 25. And maybe we should check that that actually works, because if I multiply this out, I get a 2x squared. I would have a minus 10x and a plus 5x, and that would give me this, and a minus 25. So it looks like I factored this correctly. And then these cancel, and now I find that I can just plug in 5 with no problem. I get whatever I get, 15/11. Good. Okay. Let me do, yeah, I'm at 17 minutes. I'll do at least one more. Maybe I should draw lines to separate these things. Whoops, sorry. Yeah. Sorry, I just drew a line right through the middle of part B, so this is all one problem. Sorry about that. Okay, so let's do part C. This is an elementary function. If I plug in 0 for h, I'm going to get 4 minus 4 on the top, and I'm going to get 0 on the bottom. So maybe I won't even write anything for that. Right away, I see that I can't just plug in 0 for h. So what I have to do is I have to do some algebra. For one like this, again, fundamentally, I want to factor and cancel something. Maybe I should simplify the top, because if I square this out, I'm going to get 4 plus 4h plus h squared. So I square that out, and now I see that I can combine some like terms, like I have a 4 and a minus 4. And now look, everything that's left on the top has an h on it, so I can cancel an h off of everything. So I take an h off of this, and I take an h off of this. And now I find that the new expression, I'm not in any trouble if I just plug in 0 for h. So I'm good. Yeah, so the next one's a little bit harder, and I'm at 19 minutes, so maybe I'll cut this off.